Hello, everyone. In this video, we will give a guide and tips for chapter 20 of my Java book. Chapter 20 introduces the classic data structures, lists, stacks, queues, and priority queues. Now, data structure is essentially a container object. It contains data and data objects. So you have the container objects containing objects. The container object, all these container objects are created and using classes. So the classes are data structures. So we have lists, array lists, linked lists, stacks, queues, and priority queues in the Java API. So all these data structures provide the operations for storing data, for inserting data, for removing data, for doing other operations on data. So this is a data structure. There are a variety of data structures provided in the Java API. So each has its purpose, has its use, and sometimes use one data structure and over the other data structure, depending on your application. So we're going to examine all these classic data structures, and these are the common data structures used in everyday programming. So in Java here, the data structure is designed under the framework of Java collections framework. So, and here's the diagram. You see on the right here, this column. So these are the concrete classes. So we have this, the array list, linked list, stack, priority queues, and these are the sets. So here's the hash set, linked hash set, and tree set. So this collection is the root for all this data structures. So here, collection, it branches to a set, list, and queue. And so this is the sorted set, navigable set. Now here in the middle, these are the abstract classes. And these are also called convenient classes. They partially implement the interfaces. But they're still abstract. There's some abstract methods. So it's convenient when you design your data structures, you can simply extend the one of these abstract classes, and because some of the methods are already implemented. So this is the collection interface. So please study all these methods. They're very useful and they're common to all these data structures. And so this collection interface here is a subtype of iterable. So all these data structures on the collection interface, they are iterable. You can iterate it. So you don't have to know all the detailed organizational structure of data structure. You can just go and iterate from the first one to the last one. So here is the for each default method. So this is iterator. Iterator is object. So you can iterate through it's like a pointer. So you go through every element in the data structure. So here's the test program and using the methods in the collection interface. So this here. Now, so here, this section introduces iterator, and so each collection is iterable, you can obtain its iterator object to traverse the elements in the collection. So this is an example and how you traverse it, and using this, the while loop from the beginning and to the end. Here's the collection. So this is the one. And now you can use for each method. For each method, it's simplified and the way and you write the code. Now, when you use the iterator, there's also something here, and you need to know it, that you can, this is the iterator here, you can use for each loop. Instead of using this explicit on the iterator, using the while loop here, you can use for each loop, and without explicitly using iterator, but you know that it is internally, so the system and use the iterator and for each loop. So there's for each method. It's very similar to for each loop, but it's even simpler way to write it and using one line of code. So this is the collection dot for each. So for each element, you're going to perform this action. All right, in this section, lists, and we look into those two classes, array list and linked list, and see the differences between the two. So this is the they're really very similar. The big difference is that on the efficiency, for the most of the majority of the use, you're going to use the array list, and you only use linked list if you have a lot of operations operating at the beginning of the list. You do a insert and delete at the beginning. So linked list is efficient. It's more efficient than the array list for those two operations. And the next section, we look at this comparator interface. We already have the comparable interface, and now we're going to introduce this comparator interface. The comparable interface is normally you have a class that implements the comparable interface. The objects of the class are comparable. Now, if you have the classes already designed, so you want to compare the objects, and you can use the comparator interface. And also, if you have a different criteria for comparing things, even though you already have the class implements the comparable interface, but if you want a different criteria for comparing things, you can also use the comparator interface. So the comparator interface is more flexible. Comparator interface is single method interface, has this the compare method. So here's the compare the two elements. So this is the example. You define a new class. It's a geometric object comparator. You're going to compare two geometric objects. So here's a compare method. Now this example here is you find a max using using the comparator for the two geometric objects, G1 and G2. So here is C. So how are you going to compare it? C is a C dot compare G1, G2. See, this is C is a comparator. All right, we can actually rewrite the code. Instead of using this standalone comparator, we define a comparator like this, the comparator class, and we can use a lambda expression. So here, look at this here, and we are going to rewrite the code, simplify it. From here, A, we're going to write it using this simpler code, and this is much simpler. So you have this is the this here is the you get a max. Okay, G1, G2, and here you have this geometric object, and here, so O1, O2, and so what you're going to do is you're going to this implement it. So here, if you look at this is geometric object O1, O2 here, and is instead of using this standalone, this is the class, and you make it a lambda expression. So it's much simpler. Now here, we know the strings are comparable. It's already defined in the Java API. But if you want to compare the string, different criteria here is compared by their length. It's not by the alphabetic order. So you can define a new comparator. So this is the comparator is defined, this compare the length. Okay. So this is the comparator. And you can rewrite the code, simplify the code using lambda expression. So here, simplify the code using lambda expressions like this. So here's another example here. And you go into a sort string, ignore case. So here's this is again, so we can rewrite it and using lambda expression, or and here using the method reference. So this is another way, even simpler. For the lambda expression, so we're going to use in this method to compare to ignore case. All right, so there's other things here. You can use the static method in the comparator and to perform the comparison with the primary criteria, secondary, and third, all this. So, all right, and here is the section on static methods for lists and collections. So they're very useful. You can use on the collection, on the list, the static methods, sort, reverse, shuffle, and copy, binary search. And here's the max, min, and disjoint frequency, all these methods. And this is a case study on bouncing balls. So you have multiple balls, and so this is how you organize the balls in using a data structure. And this is the discussion on the vector and stack classes in the Java API. Now, these are not actually well designed because here in the Java API, and this vector is now a subtype of the abstract list. So it inherits a lot of things from the abstract list. And so I think the big problem is actually a more it's on the performance side. It's vector has a lot of operations, synchronized operations. So it affects the performance. So the recommendation is to use array list, but if you really need synchronization and you write your code and to just synchronize that kind of part of the code you need to synchronize. So this is so it's a vector is kind of legacy code in the Java API. It was introduced in Java 2. So after array list was introduced, we mostly use array list to replace vector, but you still need to use vector because a lot of the API was developed in the past before array list was introduced. They still use a vector. All right, stack here. There's actually the design issue for stack is meant as a subtype of vector, so it really inherits a lot of methods from vector unnecessarily. So it's not a good design. So you should actually use the code. It's only having this kind of methods for stack. It's a peek, pop, push. So this kind of method for stack. but it's in the Java API, so just mention it, you can still use it. So the next section is on the queues and priority queues. Java does not have a class just for queue, and you can just use linked list for queue. And for the priority queue, Java has a class for priority queue. So here is the priority queue. So the priority queue. So you can create a priority queue, and to so priority queue is that it's like queue, but when you remove element, you remove the one with the highest priority. So you define the priority. So this is an example in how we use the priority queue. And the last section in this chapter is very useful application. It's evaluating expressions. So we use the data structures, use queues to write a code to evaluate expression. So please read this example and modify the code to add additional operators. So here we have the operators addition, subtraction, multiplication, division. You can add remainder, add exponent operator, and into this program. And that's the exercise at the end of this chapter. So if you go to the this end of chapter, so program exercise, and you can see this right here. It's see how you do this. Evaluation, modifying the code, evaluate expression, so adding new operators, exponent and remainder, and here. Okay, that is all for this chapter 20. Lists, stacks, queues, and priority queues. Thank you for watching. Goodbye.